Chapter 19. Chapter 19 is the blood. And blood is not as a chapter that's not as big as endocrine system. It's a little bit smaller. And here we're going to talk about different things, including the composition of the blood, the different blood cells, the function of each one, and so on. We will talk about all of that as a learning outcome. And generally speaking, as an introduction, we have the cardiovascular system. Cardio means what's cardio? Heart, vascular, vessels, which is angio. Isn't it the same? Angio, vessels. So cardiovascular system, the heart and the blood vessels. And when you say blood vessels, you don't mean arteries. Blood vessels, arteries, veins, arterioles, capillaries, all of these are called blood vessels. It's a general term. And the blood will the fluid part is the blood that's going to circulate inside this system. And basically, blood is two things. It's part of the connective tissue. This is number one. Do you guys remember 233? We have epithelial and connective tissue. And do you remember these? Blood is one of the connective tissues. And basically, blood is two parts, fluid and formed elements, which is the cells. Fluid and formed elements. Okay? Generally speaking, what's the function of the blood? Of course, the first thing that will come to your mind is to carry oxygen and carbon dioxide, isn't it? We all know that. Oxygen and carbon dioxide and waste products. But this is not the only thing. The next one is the blood has factors that help you to stop bleeding, right? So you don't lose a lot of blood. This is one of the functions of the blood itself. It stops bleeding. Number three, regulation of the pH. I don't know if you guys remember that or not, but the pH, remember this is acidity and alkalinity. The respiratory system help us to regulate the pH. The kidney also help us, but the blood, it does have its own system to balance and regulate the pH. The next one is defending against toxins and pathogens. And this is basically the function of the white blood cells. Remember the cells? White blood cells, red blood cells, and what's the third one? Red blood cells, white blood cells. What's the third one? What's the third type of cells, huh? No, plasma is the fluid part. Cells, huh? Lymphocytes is one of the white blood cells. Red blood cells, white blood cells, and platelets. Yes, platelets. Platelets. We have three things. So, and this give you three functions, right? We have three types of cells for three functions. Red blood cells, oxygen, carbon dioxide, carrying oxygen, carbon dioxide. White blood cells, body defense. Defense against what? Against anything. Toxins or pathogens. Okay, how about the platelets? Bleeding. It helps you to stop bleeding. Plus, regulation of the pH, regulation of the body temperature. Remember in homeostasis, when we said that the blood, if it is getting hot, your blood vessels dilate so that the blood goes toward the skin and you lose the heat, right? Versus if it's cold, your body get like pale because you're conserving your heat. This is another function of the blood. Um, the normal body temperature is 37 to 38. We can say 37, 38, depending on the location. If it's closer to the surface, that would be 37. Deep inside is 38. There is a difference? Yes. The core, the deep inside is not 37. If I put a thermometer here, it will give you 37, which is 98.6 Fahrenheit, right? 37 here, but this is something else. I'm talking about the core blood temperature, which is the deep inside, is 1 degree extra. It is the pH is something. There are, let me tell you this. There are some numbers that I want you to remember in this chapter specifically, and I will tell you the numbers as we go. There are some numbers, including here is 138. This is not the normal body temperature. This is the core blood. 7.35 to 7.45, or if it is easier to say 7.4 plus or minus half, whatever you want. But you need to remember anyway. Okay. The blood volume is about 7% of the body weight, and the amount of blood is around 5 to 5.5. The blood again is two components. There is fluid and formed elements. Fluid, formed elements. Fluid is the plasma. It's called plasma. Formed elements are all these cells and fragments. We are going to talk about it, but follow with me as we go. What's the whole entire blood? We talked about the functions, right? 5 functions. What is the blood? If I have this blood, what are the components? There is fluid, and in that fluid, there are formed elements, which are the cells and fragments. If you want to see those in a lab, in a separate parts, you do something called fractionation. They just put it in, what is it called? The centrifuge, and they leave it in a test tube, and you will see the fluid and the cells separated from each other. We call that fractionation. So the plasma, which is a fluid part of the blood, is about 55%. 90% of it is water. So what's the plasma? The plasma is a fluid part. It's watery. So it's 90% water plus other things. Okay, so mainly water. What are the other things? We will talk about it in details. But 90% is water. What is in the water? The rest. There are ions, solutes, plasma proteins, and other things. We will talk about it. So here it is. If you put the blood like this, and if you do fractionation, you will find that 55% is plasma, which is the fluid, and the 45% is formed elements. Most of it, red blood cells. Most of our cells, red blood cells. It's millions versus thousands and hundreds of thousands for the other two. Okay, so this is the plasma, which is 55%. If you do fractionation, you separate them, and 45% is the formed elements. Formed elements are white blood cells, red blood cells, and platelets. What's the measure? Red blood cells, 99.9%, millions. The other two, thousands or maybe hundreds of thousands. But red blood cells, 99%. Plasma is also mainly water. What else do we have in the water? Solutes, ions, and proteins. Solutes, ions, and proteins in the water. So we're talking about the plasma now. Plasma. Plasma is a fluid part of the blood, right? What is it? What's the composition of the plasma? It's mainly 90% water. What's dissolved? Solutes, ions, and plasma proteins. We're talking about the plasma proteins now. Here is what I want you to know about the plasma proteins. There are 3 types, and you have to know the function of each one of those. Okay? Albumin is the first one. 2 functions that you have to remember about albumin. Number 1, osmolarity. Do you remember the osmolarity? Like the viscosity, kind of viscosity, osmolarity. What's the difference between juice and honey? Honey is more viscous, isn't it? What's the difference between juice and water? Juice is more viscous. It contains more things, right? So this is one of the functions. So is the plasma, is it water? No, it's not water. If you compare your plasma to the water, the plasma is more viscous because it is higher osmolarity. Where did you get it from? Mainly albumin. Clear for this one? The next one is transport. Do you remember when we talked about the hormones, that if you leave the hormones free, we're going to lose it? It will stay for a couple of hours and then we lose it. And you have to have it on a carrier. A lot of these carriers or transport proteins are albumin. So this is what I want you to remember. Okay? Osmolarity and transport. Osmolarity, transport. Remember this. Next, globulin. Globulin is antibodies plus also transport. Here is the second transport. Are we following? Albumin, osmolarity and transport. Globulin, antibody and transport. So far we have two transports from those proteins, right? From the plasma proteins. This is also transport. It transports something else, but if you remember that it's transport, this is good. What do you call the antibodies? Immunoglobulins. Isn't this is globulin? Just put immuno before it because it's immune. Isn't the antibodies help our immune system? That's why we call it immunoglobulin. Just add immune before this. So antibodies are immuno what? Globulin. So this is one of the functions of globulin, immunoglobulin, the antibodies. The other one is transport. Can transport different things like fat. This one can transport like hormones, but both of those transport anyway. The last one is fibrinogen. Function of fibrinogen that you have to remember is blood clot. If you just want like one word or two words, blood clot, blood clot. This is what help you to do the blood clot. How? We will talk about the details. For now, it's called fibrinogen. Rule of the thumb. Terminology. What's the gen? What does it mean, the gen at the end? Precursor or generator of something, right? Remove the gen. Fibrin. Fibrin is fibers that make the blood clot. Clear? Just to make it simple. And this is what I want you to remember. So how does it help the blood clot? Fibrinogen. Activate fibrinogen, become fibrin. Fibrin are fibers that make the blood clot. Okay? It rolls around the different cells to make the blood clot. The other thing is, what's the difference between plasma and serum? If you think about it, we can say plasma is the same as serum. It's almost, not exactly. It's almost. Plasma is the fluid component of the blood inside your body. Serum is the fluid component of the blood outside of your body. It's the same thing, but inside is different than outside. What change outside? When you take the blood outside of your body, fibrinogen is active, become activated. So now we call it serum. Okay? So if I give you, if you see like in a lab, a test tube like this, okay, and I ask you, is it serum or plasma? This is serum. It's not plasma anymore. Is it different just because it's outside of the body? No, it's activated. There is a difference. Okay? Both of them are the fluid component in the blood. It's not activated until you have, unless you have injury or something. But as long as it's inside your body and there is no issue, it is plasma. No activation. Once you take it out, it's activated, and now we call it serum. Where do we make the plasma proteins? Most of it, we make it in the liver. Remember this. We make it in the liver. Antibodies. What's antibodies? Which one of the three? No, which one of the plasma proteins? Globulin. Immunoglobulin, this is an exception. We make it in the white blood cells. Plasma cells are active white blood cells, B cells specifically. So we have three types: albumin, globulin, and fibrinogen, right? Albumin and fibrinogen, liver. We make it in the liver. How about globulin? Globulin, liver also, but not the immunoglobulin. Immunoglobulin, we make it in the plasma cells. So all three types, we make it in the liver. What's the exception? Part of the globulin, which is the antibodies, we make it in the plasma cells. We will talk about the plasma cells later on. It's coming. So here are the three types again: red blood cells, white blood cells, and platelets. All three together, we call it formed elements. We talked about plasma, which is a fluid part that will become serum if you take it outside, plus formed elements. Formed elements are cells, three types. The process of formation of these elements is called hemopoiesis. If this is your first time to hear this word, cut it into two pieces. Hemo means blood. Poiesis. Did we see this like a couple of times before? Poiesis, like erythropoiesis. Did we talk about it? Poiesis, poietic. What does it mean? Formation or generation. Formation, generation. See how many times? You will see it a lot. All these prefixes and suffixes. This is what's good about this language. Okay, Greek and Latin is all about prefixes and suffixes. Once you know them, it doesn't change. Just put them together. If you know that hemo is blood, poiesis is formation, so hemopoiesis is the process of blood formation. This is how the platelets looks like. They are very tiny, and I mentioned it's important for blood clots. White blood cells, on the other hand, there are 5 different types of blood cells, and white blood cells. You need to remember the 5, and I will ask you about the importance of each one of those. Okay, what are these types? Neutrophils, eosinophils, basophils, lymphocytes, and monocytes. Okay, monocytes, eosinophil, and neutrophil. These 3 together are going to be one of the functions, the eaters, the phages. Do you know the phages, the macrophage and microphage? Did you hear this before? Macrophages. What's phage means? Phage. Huh? Eaters. Yes, phages means eaters. Macrophages, the big eaters. Microphages, the small eaters. Remember this? So how do I memorize this? How did I know that these? This is how I memorize it. Men, M-E-N. Men, eaters. Men tend to eat more. Men are eaters. Okay, so men are phages. What are the men? Monocytes, eosinophils, and neutrophils. Men. Okay, of course, this is not science, but always try to find something like this for yourself. That's going to help you a lot. Okay, always find something. How to remember it? Repeat. No, that's not enough, or it doesn't help you much. Find out something like this. Men. This is what I mean. Men eaters. Men are phages. M-E-N. Monocyte, eosinophils, and neutrophils. And then the other 2, this one is for inflammation, and this one is for immunity, and we'll talk about it more. Red blood cells. The other name is something also that you need to know. What's the other name? Erythro means what? It doesn't mean blood. Hemo means blood. Erythro, red specifically. Okay. Leuco, white. So what's erythrocytes? What sites? Sites means what? Cells. So what's erythrocytes? White cells. How about leukocytes? White cells. So these are called erythrocytes, and it's basically transport of oxygen and part of the carbon dioxide, but it's mainly oxygen. And this is 99.9%. Millions of red blood cells and only thousands of the other 2. What do we have inside the red blood cells? Hemoglobin. The red blood cells are these biconcave cells that's filled with hemoglobin. Hemoglobin. This is 2 parts. Hemoglobin. Globin is a protein. Hemo is the other part that contain the iron. Hemoglobin, this is the actual carrier of oxygen. Like what carry the oxygen? Red blood cells. What in the red blood cells that carry the oxygen? Hemoglobin. Which part of the hemoglobin? Heme. Why? Because it contains iron. And oxygen attached to iron. Clear? So where the oxygen attached to red blood cells? Iron of the heme of the hemoglobin. Okay? Oxygen and part of the carbon dioxide, but not the main thing. We'll talk about it. Rule of the thumb. When it comes to blood, all numbers of males are more than females. That's it. all numbers, anything that I give you, all numbers are more in males. Red blood cells, white blood cells, platelets, volume, hematocrit, anything. All the numbers are more in males. Okay? And this is because of the effect of androgen. It stimulates the growth a little bit more, but you have to remember this. So look at this 4.5, 6.3, and this is 4.2 to 5.5. Obviously, in males is more. Okay? Just remember it's more. And if you can remember 5 million, is that easy enough? Just remember 5 million. But it's more in males than female. I'm not going to ask you like exact number, like 5, 4.5, 6.3. 5, around 5, good enough to remember for average, but also remember that males are always more than females. Packed cell volume, PCV, this is the percentage of the cells, of these cells. And I will show you what hematocrit means. And obviously, it goes without saying, males are more than females, 46 to 42. What do you mean by hematocrit? Do you mean the number of red blood cells? Not necessarily the numbers. They used to. They used to say if you have anemia, you have low red blood cell count. But this is not very accurate. So now they use hematocrit more. So if you go to the doctor and say like, do I have anemia or not? They are not going to measure only the count. They have to measure the hematocrit. Why? Because what if you have good number of red blood cells? 5 million. I have 5 million. Am I okay? Not necessarily. Maybe you have 5 millions, but these cells are small, right? Like when I say, can you like take this job and move this stuff from here to here? Of course, I have 50 cars. What does it mean? What 50? Do you have 50 cars like sedan? Or like, is it a truck? Is it a big truck? What are you talking about? It's not the number only. It is the percentage. Can you carry 2 tons of this or not? This is what I care about. How many cars? Yes, it's important. But what's the capacity? This is another thing. So the more practical way is separate and show me the percentage of the red blood cells. If the number is high but the cells are small, that's okay. If the number is a little bit low but the cells are a little bit bigger, that's okay. Okay, so this is more practical way. Hematocrit. So if you have anemia, red blood cell count is low, but hematocrit is more important. The cells are biconcave, thicker in the periphery and thinner in the middle. Why is it biconcave? Why it's not just like this? It is not like this. It's like this. Because this has more surface area than this. If you get something and if you measure it, this is true. If you make it like this, it's different than like this. This is more surface area if compared. So that's why it's biconcave. What if it's not biconcave? This is an issue because it will not be able to do the same job. Surface area will go down. This is how it looks like. Here it is. Okay, see how it's biconcave? Look at this depression in the middle. It has to be like this. If it is not, this is an issue. This is a disease. Some people have it actually. They have it like more spherical structure, which is not good. Why? Number one, because of the surface area. Number two, if fluid moves into the cells, they move from this and become like this, right? If it is already like this, it's going to rupture. Okay, and this is a condition, but again, I don't want to go too deep into these things, but I'm telling you, it has to be like this. If it is spherical, if you move more water in or more fluid in, it will rupture. This is how it looks like. Thin in the middle and wide in the outside. So here it is, large surface area to volume ratio. This is because of that shape. So you can do the function more. You can get oxygen and release oxygen. If you have more surface area, it helps you more to do the job. It's flexible. This is another criteria. Is that important? Of course. If it's not flexible, this is an issue. Why? Because the smallest blood vessels in the body are the capillaries. Do you remember these? Arteries, arterioles, capillaries, the smallest. The diameter of the red blood cells is about 7.8 micro. And guess what? Some of your capillaries are smaller than this. Can be like 7. How can I fit 7.8 into 7? It's flexible. So it's okay. It can bend and it can go. If that's not the case, if it is hard, once you push it into capillaries that are smaller, it's going to break down. So it has to be flexible. Okay? Biconcave, large surface area to volume, flexible, about 7.8. Capillaries, some capillaries are smaller than this. It can be 7, it can be 6, it can be 5. Some capillaries are smaller. It's okay. You can bend and move through. If it is not flexible, it will rupture. Do we have nucleus inside the red blood cells? No, we don't have nucleus. Listen to the mature red blood cells. The mature red blood cell does not have a nucleus. It's anucleated. What's A in the beginning of any word? It no. It means no. No, or lack of something, yes. But remember it no, that's easier. Okay? No. A or an or M, A, N, M, I am. Those three prefixes means no. Immature, not mature. Okay? Anucleated, not nucleated. Okay? AN will serve the same purpose. Doesn't have nucleus, doesn't have mitochondria or ribosomes. So nowadays, you don't really call it cells because how is it cells? Like you don't have nucleus and you don't have mitochondria and you don't have ribosomes and I still call you cells. They call it now more of a corpuscle, but that's okay. Okay, it's okay to call it cells, but know that it's not typical cells. It doesn't have even a nucleus. Red blood cells doesn't have nucleus. Mature red blood cells, and this has a meaning that I will tell you. But remember, mature red blood cells does not have nucleus because when we form red blood cells, they do have nucleus and they grow with a nucleus inside. Grow with a nucleus inside. Just at the last step, when you're about to maturate, the nucleus is ejected out. So what's important about that? Why are you telling us this? Because if you see red blood cells inside your body that have nucleus, it means it's immature. And what's important about that? If you see a lot of these immature red blood cells, it means you're forming too much red blood cells, which can indicate something. Like I give you a simple example. If I tell you like, what time do you want to make pizza, for example, from scratch? If you give me like 2 hours, I will easily do it. Can you do it in an hour? It's not going to be perfect. How about 5 minutes? No, right? You can just add some flour to water. Here it is, right? That's immature. Is it ready to eat? No. Is it ready to work? No. Okay, so this has actually significance. If you see it with nucleus, it's immature, which means there is something that's pushing it, like maybe tumor or something. That more. You're working more. So you end up producing immature cells. Did we get this point? The other number that I want you to remember is 120 cells. This is the lifespan. 4 months. They stay for 4 months. And then we will get rid of it. Hemoglobin 14 to 18, 12 to 16. Bottom line, males are more than females for hemoglobin. Hemoglobin is heme and globin. Globin is protein. Globin is protein. How about the heme? The heme contain iron. It's not iron, it contain iron. And iron is what attached to oxygen. And what do you call it when hemoglobin attach or oxygen attached to hemoglobin? Just put the two words together, merge them. Oxygen attached to hemoglobin. Oxyhemoglobin. Make sense? Oxyhemoglobin. If you release the oxygen, you put D. D translation without. If you guys are collecting these prefixes and suffixes, that will be very helpful, not just for this, for anything in the future, anything in the medical field. You will always use these. Okay? So if you see D, means without. Deoxy hemoglobin, hemoglobin without oxygen. If you look at hemoglobin, its quaternary structure, do you guys remember primary, tertiary, quaternary structure of the protein? It's quaternary structure. It's four components. And look at the iron in the middle. So heme is not iron. Look at this. The blue and the purple, this is the protein. Look at this circular part here, and there is something in the middle that's orange. This circle is heme. The blue is globin. Look in the middle of the heme. The iron is in the middle of the heme. Fetal hemoglobin, the hemoglobin of the fetus, it is not exactly the same as adults. It is not. What's the difference? It has higher affinity to oxygen because the mom during pregnancy, the mom have the oxygen. Does the fetus have oxygen? No, he cannot get his own oxygen. Does the fetus breathe? Of course not. The fetus doesn't breathe, right? So where are you going to get the oxygen? From the mom. How can you steal it? Your hemoglobin is different. It has higher affinity. So if the oxygen is in between the mom and the fetus will take it because it's higher affinity. Like if you have two magnets and a piece of metal in between, this is stronger. The stronger one will take it, right? If the oxygen is in between, the fetus will take it because it contains higher affinity than the mom. So what do you call it when oxygen attached to hemoglobin? Oxyhemoglobin. What do we call it when carbon dioxide attached to hemoglobin? Is it carbihemoglobin? No, they added a piece in the middle, a word in the middle. It's not carbihemoglobin. This is oxyhemoglobin. Okay, this is straightforward, right? Oxygen, hemoglobin. Is this is carbihemoglobin? No, they call it carbaminohemoglobin because it attached, unlike the oxygen attached to the heme or the iron, carbon dioxide attached to the amino group. It attached to amino group, which is the protein. So that's why we call it carbaminohemoglobin. It attached to the amino group, carbaminohemoglobin. Anemia, is it the red blood cell count? Not anymore. We care about the quality, not just the number. What is so good about you having 6 million red blood cells that are too tiny and not doing the job? Is that something good? No. I care about the contents. What is doing the work for the red blood cells? It's the hemoglobin, isn't it? So my goal is to measure the hemoglobin, not the number. And that's why we come to the hematocrit, which is more important than the numbers. I want to know how much hemoglobin you have, okay? I have 50 cars. Okay. Can you transfer this? Okay, I can transfer 1 ton. The other one is I have 30 cars, but I can transfer 2 tons. This is better, isn't it? So, it's all about, it's okay. It's all about the contents, the hemoglobin, which is the hematocrit. Okay. Uh, Turnover. What's the lifespan of the red blood cells again? 120 days. And what happened then? You lose about 1% of it every day and you replace it. And we call that the turnover. And we're going to stop here. So, turnover, it's not all the red blood cells are produced same day and they die at the same day. That's not true. Okay, it's just 1%, 1%, 1%. Today, 1% will be replaced. Tomorrow, 1%, 1%. It goes like this. So, what do you mean turnover? It means we will get rid of it. We were going to break it down and replace it. Replacement is through erythropoiesis. What's erythropoiesis? I think you know now. What's erythro? Red, which is referring to the red blood cells. What's poiesis now? Formation. So this is the process of formation of the blood cells. We have stem cells in our bone marrow that's going to develop different types of cells in steps that I will talk about. Now we have two types of bone marrow, red and not white. Bone marrow, yellow, red and yellow, right? If you are a child, you're a baby, you're a child, you have only red bone marrow. So the bone marrow all over your body is producing cells. Later on, when you grow, you are going to store fat in a good part of the bone marrow. And what's the color of the fat? Yellow. So it will change into yellow bone marrow. Basically, in us right now, inside the shafts of the long bones, it's yellow bone marrow. So does it produce red blood cells? Does it produce cells? No, it does not. The ones that continue to have red blood cells are the ones that continue to produce, which are in the flat bones. Do you remember the long and flat bones? Remember this? So if baby and children, the bone marrow, all red. Long bone, short bone, any bone, whether it's long or flat, all of them. It's red bone marrow. All of it produce cells. As we grow, we'll start to add fat, store it into specifically the long bone, and this will become the yellow bone marrow, which will not produce bone cells anymore. Blood cells anymore. So what's going to produce blood cells? Red bone marrow. Do we still have it? Yes, in a flat bones. Okay. So stem cells, specifically myeloid stem cells. This is one of them that's going to produce blood cells, which is the red bone marrow. The grandmother cells, the grandmother is called hemocytoblast. You need to remember this. This is like the stem cells, the grandmother. Okay. This hemocytoblast, like the stem cells, the origin, the beginning, the grandmother. This is going to give you two myeloid stem cells and lymphoid stem cells. This is like the mother now. And the mother will give you the actual cells. Myeloid stem cells will give you all types of cells except lymphocytes. Do you remember the white blood cells? 5 types. Remember this? MEN, and then lymphocytes and basophils, right? Monocytes, eosinophil, neutrophils, lymphocytes, and basophils. Lymphocytes, this is one of the 5, right? This is the only exception that doesn't come from this mother, the myeloid stem cells. So myeloid stem cells makes everything except one of the 5, which is the lymphocytes. So it goes like this. From hematocytoblast into the myeloid stem cells that's making most of it. It will maturate and become pro-erythroblast, and then erythroblast, reticulocytes, and then it will become red blood cells. Guess what? Myeloid stem cells, they have nucleus. Pro-erythroblast and erythroblast, even reticulocytes, they have nucleus, and then it will be ejected out. And now you have mature red blood cells. So what if I see erythroblast or reticulocyte? These are immature, right? Everything here is immature. This is a mature red blood cells, the last one. Anything before that, it's immature. So if you have reticulocytes, a lot of reticulocytes in your blood, it means you're releasing the red blood cells that's immature, which means there is a condition, there is an issue. So here it is. Look at this. Ejected out. And then the mature blood cells, they don't have any nucleus. The hormone erythropoietin EPO, where do we produce it from? I mentioned it today. APO. Where do we produce this hormone? Hmm? Kidney. What else is produced in the kidney beside this? Calci, calcitriol. Remember, calcitonin is something else. Calcitonin, tiny. Calcium, calcitonin, tiny. Low calcium. This is something else. But this is calcitriol, which is active vitamin D, right? And what's the third one? That's an enzyme. Renin, yes. Follow with me as we go. Okay. So erythropoietin, it comes from the kidney. What stimulate the kidney to produce it? Less blood, less oxygen going to the kidney. Do you think the kidney is like very smart? It will understand without a tool, without something to tell them. They have to sense it somehow, right? Less blood going to the kidney, less oxygen going to the kidney will say, okay, now we don't have enough. I'm going to produce EPO, go to the bone marrow, red bone marrow specifically, to make more blood cells. The process of erythropoiesis, this will be the last thing. Erythropoiesis, in order to make the red blood cells, you need many things. Okay? What do we have inside the red blood cells? Hemoglobin. So you need heme and globin. What's a globin? A protein. You need the protein. This is one. And what do we have inside the heme? Iron. You need iron. Okay? Plus, there are vitamins that help the maturation process. Look at this. You see this, how we are moving from 1 to 1 to 1? You cannot do that if you don't have these vitamin B12 and folic acid. If you don't have it, they are not going to maturate. Okay? And you'll end up having another type of anemia. Does all the anemia is iron deficiency anemia? No. Most of it is iron deficiency anemia. You're not getting enough iron, but is that the only thing? No. If you don't have enough folic acid or vitamin B12 specifically, these cells are not going to maturate and you will have anemia, but a different type of anemia. Let me tell you this. I will finish here. What did you notice in the size? Compare this to this to this until you get here. Isn't getting smaller? Smaller, right? So as you maturate, you become smaller, smaller, smaller. And what help you to maturate? Two vitamins, B12 and folic acid. So what do you think will happen if you're not maturating? Your blood cells will be bigger or smaller? Bigger, bigger. Okay? And this is another type of anemia. If this is iron deficiency anemia, just the problem is here. Okay, you don't have enough iron, so your cells become small. But if this is vitamin B12 or folic acid, it's the cells become bigger. We look under the microscope and we see the cells like doubled or a time and a half as big. Did you get the rationale? Did you get why this is happening? If the cells are bigger than normal, if that's the case. And we will stop here.